Please go ahead. Thank you very much. Well, I'm delighted to be here. This is my third visit to Japan. My first time in Japan was back in 2008 for my honeymoon with my wife. We spent 3 wonderful weeks in this wonderful country. The following time, it was already on business, and I came to visit an OHDSI Japan meeting organized by Professor Hiramatsu in 2020 with my son. 2020, it was early 2020, actually. Yeah, very brave, just before the pandemic hit. It was February, I think, 2020. And this is my third visit. I have very strong love for this country. I really like your culture, your gastronomy, your sightseeing, your temples. I'm pretty sure I'm going to be coming back and bothering you again. In these 4 years, a lot of things have happened, including a very sad pandemic that kept us, on our toes, and that led to many people having problems and loss of life. For me, professionally, it meant a very speedy progression in my career, becoming a professor of pharmacoepidemiology at Oxford, and then more recently, a joint professor at medical informatics in the Erasmus Medical Center in Rotterdam, which is the coordinating center for OHDSI Europe, and also in the last year, the lead for the OHDSI UK national node. So I'm leading with another colleague the OHDSI UK node. Today I was asked to speak about federated analysis, how we do these things in OHDSI, and specifically federated analytics within one country, not so much international collaboration, which I think was covered by Mui before. It is very hard for me not to collaborate internationally. So you will see that there's still a lot of my slides that talk about international stuff. I will aim to speak about these 4 topics for the next 50 minutes, maybe, and then we should have plenty of time for question and answers and discussion. So with no further ado, I will start talking about open science and federated analytics. I read in between all the Japanese characters open science a few times in the previous presentations, but I don't know how much of overlap there's going to be between what's been said already and what I am saying now. Hopefully not so much. Okay, so there's many reasons why I believe collaboration is important. There's many reasons why I believe federated analysis encourage collaboration, and one of them is these slides that Matan Shumi presented some years ago, where he did a systematic analysis of more than 200,000 estimates from different studies, observational studies published in PubMed, and found this interesting kind of funnel shape. I don't know if anybody is brave enough to tell me what you think is the threshold that we see, that kind of line that you can intuitively see in the picture. I only know a couple of people in the audience, so I'm going to volunteer them all the time if I have no volunteers. The two of you want to give it a go? Do you think you know what that could be? That line that you can intuitively see there? Which p-value would you say? So this sadly, I would say, this is the p-value 0.05. Yeah. So as you can see, if you look at the whole lot of literature published out there, there's very strong evidence of p-hacking. People tend to publish only studies and results that are significant, that have a p-value below 0.05. And that's why you have this clustering of dots, immediately below the threshold, and very few dots in the middle, where actually you should expect to have the same probability of findings. This is bad. It's really bad, and we need to combat this. I do not think that we're going to have hundreds of years to fix real-world evidence. We're going to have 1 or 2 shots, and if we don't get it right, we will just go back to the old ways of just doing randomized controlled trials and not looking at people who are not recruited in trials. So I think it's very important that we work together to minimize this. And the way forward for that is using open science principles. The first open science principle I want to strengthen or highlight is the need to declare a protocol, a very well-specified protocol before you do any analysis. This is something we learned with clinical trials ages ago. You shouldn't allow people to do trials unless they declare publicly that they are doing a trial. So you can then say, hey, where are your results if they don't publish them? And we need to pursue similar practices in real-world data, real-world evidence. The second thing we need to do is share all our code. And when I say our code, I don't mean our code lists to identify conditions. I mean our analytical code. So all the analysis that we do, so that colleagues around the world can take that piece of code and run it in their data and replicate your analysis. And finally, of course, we need to share all our findings, regardless of whether we think they are interesting or not interesting. We need to publish and disseminate everything that we do so that at the very least, we prevent other people from having to do again the same amount of work that you've put into that analysis. And only by doing all this, we will get to a situation where we are perceived as fully transparent, trustworthy, and actionable for people like regulators or payers or important decision makers around the world. I think this is not something unique to Europe or to Western cultures. It's everywhere that we need to gain this trust by being very thorough and following these principles. So now this is what happens when you follow those principles. This is the results from a study called Legend. This is a study where colleagues in the OHDSI community compared all the antihypertensives to each other and then published a very nice paper in the Lancet. But they also have a shiny, a kind of interactive application where you can see all the results from that study. And there's almost 8 million estimates from that study because there's loads of outcomes, lots of comparisons, medicines to each other. And what's really interesting is that now here you do see what you are expecting, right? So there's no longer any evidence of p-hacking. Compare that to the plot at the right hand side of the screen. Yeah, this and not that is what we need to aim for. Okay, so how did we grow at the pace we have grown in Europe? So there's been a few initiatives. I'm going to talk about at least a couple that have catalyzed and galvanized the use of OMOP and federated analytics in Europe. The first one is the EDEN project, European Health Data and Evidence Network, where I am the research coordinator, led by Professor Peter Reinbeck, where we had two bits of work going on. One was open calls, grants, money going to institutions who were interested to map their data to OMOP. Yeah, and it was a competitive process. They wrote an application and we had a panel of people who selected the best, the most interesting data, and then we gave them grants to map their data. Yeah, and on the other hand, we had open calls for training of IT companies who would be either supporting the mapping or at least checking that the mapping had been done well. Yeah, so these were called SMEs, small and medium enterprises from all over Europe. And we created, by doing this, a beautiful life cycle of more, as you will see, almost 200 data partners from Europe who have mapped their data to OMOP. And a few of those, or maybe many of those, will continue to refresh their data and do this regularly, enabling research that's very much needed. I'm not going to cover the OMOP common data model because I think this has been discussed before, and although I can't read Japanese, I could see in the pictures that you were discussing this already, so I'm gonna skip this slide. Yeah, the principle of federated analysis. I think you probably covered this a little bit as well, Professor Hiramatsu, but in Eden we had this idea of federated analytics where we have a central hub or a platform where somebody is leading a study. They use the tools available to the community from OHDSI, like Atlas, that has been discussed before, and potentially others. We have Eden specifically developed tools like treatment patterns and other packages that have been created. And then we would share we would share code, analytical code, with the different data partners. and they would typically have a local database in their source instance and source format, but then an OMOP database as well. They would run the analysis on OMOP and then share the results with us. And this is the way you do federated analytics while preserving privacy by design. Yeah, so you never move patient-level data. You censor in all these tools that we develop, you censor the number of patients, so you never have very small numbers. And by doing this, you basically only handle analytical code and anonymized aggregated data. Here's the Eden network. As you can see, 187 data partners from all over Europe. And I think it's something like 350, 400 million people records. Now, because I was asked to speak specifically about the UK, I'm going to also give you the parallel picture of how things have been evolving nationally in this one country. I think you can tell from my accent that I'm not a Brexiteer or a supporter of Brexit and the detachment of the UK from Europe, but things have happened in the UK in parallel and many other countries in Europe as well that I think are worth discussing for the national audience that we have today in the room. So the UK is setting up this secure data environment. There's going to be this total of, I think it's over 10 secure data environments. There will be locked environments where NHS, hospital, and primary care data will be contained, and there will be a way to access that data securely. But the data will not be transferred to researchers anymore as it was in the past. This has limitations. It also has the strength that it's unlocking access to data that we never had, like loads of hospital records with very rich information are going to be made available for research. Like it or not, this forces us in the UK to use some sort of data model and common data model and federated analytics, right? So this is, I guess, Professor Chan, similar to the situation you have in Korea as well. So we have a lot to learn from you on this. Luckily for us, because I can promise you I didn't have any impact on this or any influence, NHS England, who is the owner or the steward of all this data, decided that the common data model they should go for is OMOP. So all these data assets are going to be mapped to OMOP. In fact, the one where I live, which is Thames Valley, Surrey, so that's Oxfordshire and the surrounding areas, it's around 4 million people, is already in OMOP instance, and we will be able to do research on that data using OHDSI and other tools very soon. Okay, a second point I wanted to discuss is my second biggest motivation for standardized data and federated analytics, in addition to encouraging collaboration and minimizing p-hacking and bad practices. And it is the fact that once you standardize data, you can start thinking of investing in standardizing your analysis as well. I have been in the real-world evidence business for about 15 years, and this thing you see in the screen that people younger than me talk about as if it was from the 20th century, this is the stuff that I was doing myself when I was doing my PhD and, you know, when I was a postdoctoral researcher. So you would have data from different countries, in my case, mostly in Europe, that had very similar information actually at source, but that looked completely different. Yeah. So even if you had to do a study, a simple study on something like, let's calculate, let's do a drug utilization study. Let's see how long do people take statins. Yeah. You would go to the data set, say, oh, this is what I want to do. And you would need to recode everything and have a single script for each of those data sets, either to convert the data in a minimum data set or to analyze the data one at a time. Yeah. And this was not only extremely painful, but also very expensive, not transparent at all, not reproducible, and very, very slow, which is not very good for someone as impatient as I am. Now, having the commitment to map the data to one common data model and not 20, then enables a massive community of people who know how to do this stuff to invest all their resources in one way of doing things, right? And the beauty, the strength of the OHDSI community and the OMOP Common Data Model is that there's a massive community behind you writing tools, standardized analytics, pipelines that can do specific analysis always in the same way. You can modify those pipelines, but they are, fully tested. They are software. They are not just analytical code that somebody has been writing. So now that you have all your data, for example, you see here from many countries, including Japan, in the same format, now you can invest in saying, oh, wouldn't it be great if we had a package to do drug utilization studies that could look at, adherence to treatment or doses or, anything related or characterization of indications for treatments. Wouldn't it be great if we had a package to do incidence and prevalence, as you mentioned earlier? Wouldn't it be great if we had a package to do comparative effectiveness or safety? And that investment can only be done if you are putting the whole community behind one pillar. There's many reasons we are investing in this. One of them is that we need to scale up. So the need for real-world evidence has become very obvious worldwide during the COVID pandemic. And now many regulators around the world, including Japan, I believe, are using real-world evidence to make decisions all the time on which drugs should be approved or not approved, and what indications should be used, and many other aspects. So in this particular initiative that I will explain a bit later, called Darwin EU, we have the ambition to do this year 72 studies. 72. I don't know if anybody here has ever done 20 studies in a year. Multinational studies. I don't know anyone who's done 20 multinational studies in a year. This year, our teams will need to do 72. So this is something that that keeps me awake at night, but I'm pretty sure we can deliver this with the tools that we have created. So to hack this problem, there's basically 3 types of analysis that we are committing to do. One is these off-the-shelf studies, which are basically a little bit like IKEA houses that you can build from scratch very quickly and always in the same way. So there is no need to have 100 different ways to calculate an incidence rate. Maybe you can need 10 ways to do that, but not 100. And if you pre-specify those and create software to do that, as we did for incidence prevalence, then you can do that very quickly, right? We then have the idea of complex studies where you will need to write some code, but mostly you will be using existing packages. And finally, and this is, I think, gonna give up where I come from originally. I'm from Barcelona. This is a very famous church called La Sagrada Familia that was, I think they started building it in the 19th century and they haven't finished yet. So that's how long it's taking. Hopefully our studies won't take so long. But we will have these very complex studies that we will do now and then, where we will have to write, allegedly, a lot of code. So to achieve this, and I'm sharing this in case this is useful for people talking to your managers or national stakeholders, we sat down with, in this case, the European Medicines Agency and wrote this catalog of standard analytics. So this is the catalog of studies that we think we are going to be doing repeatedly. And basically, there's 4 types of analysis. One is patient-level characterization. So this is getting a cohort of people and characterizing them, looking at what they are like. Second is patient-level drug utilization. This is where you get a cohort of uses of a medicine and look at how they use that medicine, what indications, what doses. The third is population-level drug utilization. This is looking at uptake of medicines in populations. And finally, population-level descriptive epidemiology. This is incidence, prevalence, and so on. And then we have the complex types, which I'm not going to cover in detail for the sake of time, but basically they include the usual causal inference pipelines. So comparative effectiveness, safety, self-control methods, new user cohorts, and stuff like that. Now, examples of use cases that we do for population level disease epidemiology. We do studies like on the prevalence of a rare disease. How rare is a rare disease? And this is important because sometimes decisions on whether a medicine should go through a regulatory path or another, depend on how rare the condition is. We also do studies on the background rates of potential side effects. So you want to know how often does something happen in the general population, so that when you have the people having a vaccine or a medicine, you can compare the rates in that population to the background rates. And this is a very common method used by the people in pharmacovigilance. When it comes to patient-level disease epidemiology, this is the characterization of cohorts of people. We typically look at natural history, prognosis, current practice, how are people being treated, what sort of treatment patterns do you observe. Population-level drug utilization is basically monitoring the use of a medicine or a group of medicines in a population, so incidence and prevalence of use, typically over time. And then finally, patient-level drug utilization is where you will be looking at what are the indications of a drug in the community? Is there any off-label use? What's the duration of treatment? What's the cumulative exposure and stuff like that? So we do use many of the tools available in the OHDSI community, but we also had to build some bespoke tooling for the EMA, following their specifications and their wish list of things they wanted to do. And we have a set of, as you can see here, I think it's now 7 packages. Maybe there's more that I haven't got here. A set of tools that basically do precisely what we need for these off-the-shelf studies. So that's, you have an incidence prevalence package, you have a patient profiles package for characterization, and so on and so forth. The first package we developed is this package called incidence prevalence, which, as the name says, calculates incidence and prevalence. And we validated this package. Well, we did lots of testing and so on, but then we did a clinical validation, also replicating a study that we had done looking at the incidence of adverse events of special interest, where we wrote bespoke code. We compared the results to the results obtained from incidence prevalence and showed very similar findings. We also compared the incidence rates of COVID-19 in the UK and in Catalonia, Spain, using real-world data compared to the official national figures. And the real-world data was, the incidence was calculated using incidence prevalence package. And you can see how if you omit the first wave where, well, national figures are lower because there wasn't enough testing in the community. After September, October, where testing was fully available in the community, the rates are very much the same in the real-world data with incidence prevalence and the official figures. We also monitor and document software performance in different data sets. We try to disseminate as much as possible all the software that we create in public repositories like CRAN, but also when possible in the form of publications. And this is a paper illustrating the incidence prevalence package that we published in Pharmacoepidemiology and Drug Safety, which is a very niched journal used by people who are in the business of pharmacoepidemiology. I'm now going to cover some examples that I think are interesting, that I think are cool, and then I will finish covering the true impacts of this work, which is doing research for the European regulator and a kind of a seed project that we have now to do something similar in the UK. So you might think simple characterizations are boring and they will not get you a good paper published anywhere. It turns out that is not true. This is a paper we wrote in 2020. It got published in 2021, sadly, because the publication business is very slow. But this is a paper we wrote in 2020 where we were interested to see what kind of treatments were people receiving when they were admitted with COVID-19, hospitalized with COVID-19. This was published in the BMJ, one of the top 10 journals worldwide. And our observations were quite interesting and I think show how little we knew about how to treat this condition. So we had data, as you can see, from China, South Korea, so you have 2 APAC members there, and then Spain and the USA. And you can see how, for instance, hydroxychloroquine was extremely popular in some hospitals in Spain. Up to 85% of people admitted with COVID got hydroxychloroquine, but much rarer in other parts of the world, like South Korea, where it was like 27%. And if you look at medicines that we know work, like dexamethasone, very, very heterogeneous use, very, very rare in Asia at that time, much more common in other parts of the world. And so it goes. Azithromycin, for some reason, was extremely popular in Spain. And as you can see, also quite popular in the US, although we have later on learned that it's not an effective medicine against COVID-19. I always use these slides just to tease people who think that trials are the only way. If you remember the timeline of what happened with hydroxychloroquine, the FDA approved as an emergency authorization hydroxychloroquine to treat severe COVID in late March. In mid-April, together with the OHDSI community, we published a preprint and then a paper showing that hydroxychloroquine was less safe than we initially thought. And that already led, together with other papers by other people, of course, led already to changes in guidelines and to changes in regulatory approvals. And you can see already how after that, in May, you already see a massive decline in the use of hydroxychloroquine worldwide. The results from the trial that demonstrated, the first trial that demonstrated that hydroxychloroquine didn't work, came up only in June. And by then, we were not really using hydroxychloroquine anymore. So this is a very beautiful example of how real-world data made a difference before trials could show that, that this medicine was not effective against COVID-19 and just based on safety. Now, comparative safety, this is, of course, the gem of the crown. We have the ability, when we collaborate internationally, to do very large studies. Very large studies are interesting always. You know, everybody likes large data, but they are needed, they are necessary when you're looking at very rare events. Like if you're interested to know whether a vaccine causes an event like thrombosis with thrombocytopenia, which happens in 1 in 200,000 to 1 in 500,000 people, you clearly are going to need many millions of people to study that. And that's exactly what we did here. This is a study where we used data from 5 European countries and the US, including some microbia data, as you heard earlier. We used state-of-the-art method really to minimize confounding. And we included many, many millions of people in this study to find in the end what was kind of suggested from previous studies, and it is that the adenovirus-based vaccines were leading to a higher risk of thrombocytopenia and probably to a higher risk of thrombosis with thrombocytopenia compared to the mRNA-based COVID vaccines. Again, another paper in the BMJ that we published. And more recently, because I wanted to focus a bit on the national picture, we have been doing this study in collaboration with the national regulator in the UK, the MHRA. This is a study that we did as a study-a-thon, so we did this in a week. It's a study that basically aimed to learn whether regulatory actions to minimize the use of fluoroquinolones would lead to a reduction in the use of those antibiotics. And although there was previous data on this, what nobody had done before is looking at the use of medicines in different sub-regions or devolved nations of the UK, and also in different healthcare settings, not only in primary care, but also in hospital care. So just to give you a bit of background, fluoroquinolones are very popular antibiotics that I, as a physician, have prescribed many times. And they were at some point being used even to treat minor infections like urinary tract infection, as well as more severe ones. Their use increased in popularity over the years. And only then we started learning of potential very severe side effects, initially including tendon rupture, but then also more recently other potential life-threatening conditions. As I don't know the results of your study, Chan, on aortic aneurysm. I don't know if you want to disclose that later, but this is clearly one of the worries, that if these medicines affect your collagen, they could be affecting more than the tendons and potentially, you know, your arteries and your retina and other parts of your body. In any case, these very severe side effects seem to be much more common in older people and in people who take steroids. And based on this, many regulators around the world took action. The MHRA in particular recommended only using fluoroquinolones for very severe infections when you cannot use anything else, and being very cautious if you are giving them to someone who is old and on steroids. Yeah, so that's the recommendation. In 2019, they issued that piece of advice. And then what we did together with the UK MHRA was to design and do this study-a-thon to estimate the impact of this regulatory action on the use of fluoroquinolones in the whole country. And this is why I wanted to bring this example up. In different parts of the country, in primary care versus hospital care versus outpatient care, and in older and younger people. We had the luxury of having many colleagues in the UK who had previously mapped data to OMOP, and we had data from primary care, data from hospitals, and linked data linking primary care and hospitals, and also different geographies, different regions of the country, different nations. We had data from Scotland, from Northern Ireland, from England, and from London, which is not a country, but it's massive. We used standardized analytics. We didn't write bespoke code to do these things. We had these three packages that we used. We used incidence prevalence to calculate the incidence of use of fluoroquinolones over time. We used patient profiles to characterize the people who were receiving the treatments, and we used drug utilization to calculate how much of these antibiotics people were receiving. We stratified by month, calendar month, and also by age to look at whether there was a different effect amongst people below or older than 60. And then finally, we modeled this to see whether there was a causal impact of the regulatory action using two different methods, interrupted time series and ARIMA. Just showing you some preliminary findings. This is data from a very large London hospital, Royal Baths, NHS, Baths Health, where you can see how in red, the observed rates of use of fluoroquinolones dropped dramatically, I would say, in this case, after there was the regulatory action. And the green thing that you see is the prediction, what would have been the trend without the action, yeah? And the red is the actual action that you see, the actual use of these medicines. So basically here, the use dropped pretty much to zero. This is now linked Scottish data that includes primary care and hospital data. And again, you see a very clear effect. In this case, the effect, I would say intuitively enough, is more clear in the people older than 60, which is the top half of the screen, compared to the bottom half, where you have the younger people. The regulatory action said very clearly to be cautious in people over 60. So it's to be expected that most of the impact is on older people. And you do see, again, beautifully, a very clear example of regulatory action followed by a change in practice by clinicians. This is a little bit less clear. This is data now from CPD Aurum, which is only England. And here, I wouldn't dare to say that I see much of a difference. You can see how the red and the green are intertwined and very close together. So we don't have very strong evidence that this regulatory action made a big impact on primary care in England. And then using the same method, using different methods, this is now the London hospital again, but using ARIMA, which is a different method. Again, very consistent results. The Scottish link data using ARIMA, very similar results. Okay, so in summary, I think we have demonstrated in this one proof of concept study that we did with the regulators in the UK that using previously developed software and previously mapped data to the OMOP CDM and federated analytics, we can do very important studies for them very quickly. There was a previous study done on this topic that took months, and we did this, as I said, in a week. And we can also involve colleagues who have data in completely different formats, like primary care and secondary care, or Scotland and Wales, use completely different software to record electronic medical records. So using a common data model and federated analytics allowed us to look at the impacts in different healthcare settings in different sectors of the population. Okay, I want to finish just talking about two pieces of work that are ongoing. One is very well ongoing, and the other one is just at the very early days. And this is work that we're doing with European regulators to help them produce the real-world evidence that they need. Because I'm the deputy director for Darwin, now every time I talk about Darwin, I have to put up these slides just to say that this is me talking, not the EMA, not any of their parties. But yeah, clearly, regulators have an increasing need for real-world data. They are increasingly appreciating the need for information intelligence on how medicines and medical devices are being used in the real world out there, and not only in the trials or in the very specialized academic centers where everything looks pretty and follows guidelines. So there is a very clear increased need for real world evidence, and regulators have very clear ways of doing things. When they ask for evidence, they want it to be fast, but they also want you to be extremely transparent on how you did everything. They want you to be scalable, so you can do many studies for them, and they want reproducible research. Yeah, so they want everything. They want fast, transparent, good, scalable, reproducible. In the case of the EMA, they also, where possible, want to have representative data from different regions of Europe. This is how we work. We have the Darwin Coordination Center right there in orange, where we basically have a pool of people who can design, write code, and execute studies. We have the European Medicines Agency and their committees and national committees asking for questions. They bring those to us. We then liaise with our data partners in a federated network, share code with them, get results back, compile them, write a report, and send it back to the European Medicines Agency in the hope that that is used to make decisions. And this is the flow of information. Basically, the EMA and their committees identify questions that are potentially important. They then drill them down to us. We look at whether the questions are feasible with the data we have. If they are, we then write a protocol. We apply our analytical tools. We share the code with the data partners. So we're now down here. They run the code. They check the aggregated results, share them back with us, and then we compile them, write a report, and share that with the requesters, so the EMA or the national authorities. And hopefully that informs decision-making at the European Medicines Agency. These are the first 10 partners we had. We incorporated in year one of Darwin. We had information on 26 million people from, as you can see, 8 countries, including primary care, biobank, claims, hospital data, and so on. This year, we are now starting the 3rd year, but in the 2nd year, we incorporated another 10, and we now have 20 data partners. Now we are very lucky to have colleagues from, for example, Norway, where they can link at the person level all their registries, a beautiful data set covering the whole population of the country, similar with Finland, similar with Denmark. And we have now got also data from other countries that were underrepresented before, from Central Europe, like Hungary or Croatia. So we have now loads of data that we can analyze. And it's a very exciting time for us in the coordination center to collaborate with these 20 colleagues, 20 data partners. We're now including, therefore, information on more than 130 million people in Europe. And we are going to be increasing the number of data partners in the next 2 years to a total of 40 data partners by the end of the project. I will not go in detail through the different studies that we've done in Darwin, but just to tell you, we've done studies on things like the prevalence of rare blood cancers, the use of valproate-containing medicines in pregnant women or women of childbearing potential. Sure, you've heard the issues with this medicine in pregnancy. Strategization of antibiotics in the context of potential shortages and also potential antimicrobial resistance. It's very important that we monitor how we are using antibiotics in Europe. Studies on severe asthma, studies on multiple myeloma, studies on opioids, you name it. We have completed 16 studies in the past year, and from February 24, we've started this year 3 of Darwin, where, as I said, we need to deliver around 70 studies, including 12 complex ones. Now, very, very early days, very, very breaking news. The UK MHRA, the UK national regulator, opened a competitive tender for the formation of regulatory science networks using data from the UK. We put in an application to set up one coordinated from Oxford using OMOP, and we got shortlisted. So we are now writing the stage 2 application that we will be submitting this summer. We have very good colleagues and data partners contributing to this from CPRD, from the UK Biobank, from Barts Health, from North West England, Lancashire, from London, a very specialized pediatric hospital, from Scotland and from Wales. And we will be using, of course, Open Science, Federated Analytics, the OMOP CDM, and the standardized analytical packages that I've been talking about, and all the OHDSI packages, and potentially something else we might need to develop specifically for the MHRA. So watch this space. I'm hopeful that maybe in a year or two, you will be hearing the first results from this collaboration. I think I'm going to finish there and leave you my email there in case you want to contact me or have any questions. I think we have plenty of time for discussion now, right? Thank you.
Very much. Okay, so I'd like to start the questions thread as one of the Asian people. So I have 2 questions. First of all, why Europe or UK choose CDM or OHDSI as your standardized framework to unite your databases across the countries or across the regions? Since there are many other format, or you may develop your own data models. Why possibly not? So that is the first question. And second is, so do you think that whether it is possible to build a very large network between between countries or between continents, such as between Japan, Korea, and Europe or UK? So what's your perspective on this?
Thank you, Chan. Yeah, so I guess it's hard to say. I don't take anything for granted. I come from a humble family of working people who never take anything for granted. I don't think that we can assume that OMOP is going to be the common data model that Europe or the UK are always going to be using. I think that there are a number of projects going on with different common data models. I think what's happened is that OMOP has naturally been selected by delivering what was needed when it was needed. So we had projects like Eden that promised to map 100 million patient records to OMOP, and we mapped 300 million patient records. When there was a problem with a very important problem with a public health issue with COVID, we delivered the evidence that people needed, like the European CDC or the European Medicines Agency needed. When there was an emergency with a vaccine potentially causing harm, we delivered the studies that were needed very, very quickly. And therefore, I don't think it's been a kind of conscious choice. It's been more of a competition, I would say, that we have managed to deliver very well on. Including like Darwin EU was a competitive tender where other colleagues from around Europe who use other common data models probably also applied. And it was a very tough competition, and in the end, we made it. So don't take anything for granted. I think we need to keep fighting. To me, the most important thing, to be honest with you, is that we commit the limited resource that we have as human beings to one joint venture. I don't think it's clever to have 20 common data models and then have 20 sets of tools that are running around. And I think the real beauty of OMOP, in my personal opinion, is that I am here in Japan talking about OMOP today. I'll be in Korea next week, and I know that people are trying to map data to OMOP and to collaborate. And last year, I was in Australia doing the same. And, seeing there's a community trying to do this is what really, is thrilling and exciting about OMOP. And I don't think that happened with all the other data models, to be honest. This kind of open science perspective opens a lot of opportunities for collaborative efforts. And I guess answering your second question, I think that it's been proved that we can do this internationally. I don't think I know any other collaboration of this size and of this relevance. I remember very vividly when I came back from Japan to the UK in February 2020, having calls with you in Korea at 6 a.m. UK time and having calls with Los Angeles at 9 p.m. UK time, which was our crazy working schedule. But I think we proved very nicely how you can write papers with 15 data sets or 20 data sets from 10 countries and 3 continents, right? So I think very, very clearly, if we do things right and we continue being collaborative and, I guess competing against viruses and not against ourselves, we can really make a difference, and we can build this, strengthen this international community.
Very much. Thank you very much for your talk. It was curious. So, 2 questions. One question is speed that you have been doing studies in Darwin. That was extremely inspiring. And so, questions that you in the talk you justify some studies like default, preset.
Yeah.
So what is your thought about the speed, like in Darwin's among 20 studies like that? But it's a great.
Yeah. So I think I said already that I am a very impatient person. So I like speed, not in the roads or anything like that, but when it comes to delivering science, we are all patient today or tomorrow, and we are all going to need data and want data immediately, not in 3 years' time, because depending on the condition, the diagnosis, you might not be there in 3 years, right? So I believe, as a clinician myself, I believe that evidence needs to be delivered as quickly as possible. Now, I also believe that we should never sacrifice quality for the sake of speed. And that is why when we wrote this catalog of analysis, I very specifically, because I was the one leading this catalog, very specifically created a group of studies that can be done very quickly, because I know the analysis that you need to do can be fully pre-specified. You don't need to reinvent the wheel every time you calculate a prevalence or an incidence rate. You don't need to reinvent the wheel every time you're doing a Cox regression, right? So for those things, if you agree with your client or your customers or your evidence requesters, how should we calculate an incidence rate to fulfill your needs, you can really achieve very, very fast speeds without sacrificing quality. And if you ask me, probably improving quality, because once you've settled on how you do an incidence rate with the 20 or 30 parameters that you want to consider, if you don't depart from that, the room for error is minimal. Whilst if we have to sit down with 20 epidemiologists to discuss how we calculate an incidence rate and then get 10 statisticians to write data or R code to do that, that makes me much more nervous. The room for human error there is multiplied by a factor of 10, I think. So I think the real key is finding that fine balance between, I'm not going to give you a different study every time, but if you commit to 10 or 20 different types, we can very clearly move to a space where we can do studies very quickly and without sacrificing quality. And the way I see it a little bit is the analogy I use is that this is a set menu, not a la carte, right? So if you have a set menu of things that you can deliver, that you want to deliver, you can have 80% of the work done a priori. You can have your rice and your sashimi and then prepare the nigiris very quickly. If you say a la carte, you do whatever you want and you have to go and fish the fish that I want, that takes months, right? So clearly it's all about pre-specifying and agreeing a priori how we do things and what is our wish list. And then you can go spend time developing tools, pipelines, and then do studies very quickly without sacrificing quality at all. I hope that makes sense.
Thank you very much. The question is also related to time, but I think I think like particularly for regulatory purpose, we spend a lot of time in documenting like things we have been proud about. So how, in particular, the multi-country studies, I think application. So I don't know how much important in the local variance.
Yeah.
Which is, and also, you develop the role of statistical analysis. Is there anything that like video points separate?
Yeah, excellent question again. So once you've resolved the technical side of things, which is what I discussed first, now the second part of the delays in these studies are human or social factors, right? And that has to do with writing protocols, writing SAPs, or governance, like having permissions to do studies. What we've learned in the first 2 years of Darwin is that most of the times, if you really have a well pre-specified way of doing things, you can convince people that the same protocol, just changing one condition for another, can be reused all the time without need to rewrite and reinvent every single time. So as I said, if you're going to be doing incidence rates 10 different ways, but not infinite different ways, you can write 10 protocols for incidence rates and then just replace COVID-19 with influenza or replace valproate with thalidomide and change one with the other and get the protocols approved. Some data partners in Europe have even agreed that we can have what we call a blanket protocol, where we say, this is how Darwin wants to do incidence rates. This is how Darwin does drug utilization. And then instead of sending a new protocol every time, what we have is basically an amendment where we say, and now we also want to do these other drugs, right? And they approve it, because otherwise their job is quite boring, because they are going to be reviewing 100 protocols that are exactly the same, only changing the name of the medicine of interest, right? So it's, again, if we play the standardization card there, I think we'll be in a much better place. And my final point on this topic, I think we need to invest time and effort, resources in creating tooling. We're in the ChatGPT area, right? We need to create tools that create code from protocols. If we agree on how we do incidence rates and we have a protocol that has been pre-specified, there's no reason you cannot write the code pretty much in a semi-automatic way from the protocol that you've written. And even protocols should be written in a semi-automatic way where you say, it's not an essay, it's not a pretext thing, it's a multiple choice questionnaire, right? Where you say incidence rates from 2010 to 2020, stratified by month, age, sex, and I want database A, B, C, D, and these are the medicines of interest, and you then create a very quick protocol from that. that has been previously reviewed and approved. So it's already ready in the oven, waiting for you to pick it up.
Real interesting talk. I have two questions which are a little bit related, and I might have already asked. But so once some data has been mapped to the form of CDM, but the data itself will be updated as time goes by, then do the users like us need to ask the data partners to do the mapping again, or do they have some built-in system, something like that, so that they can almost automatically map the data into CDM?
Yeah, I will tell you my side of the story, but I will admit upfront that I am not an expert in ETL, and Mui probably, if you can pay attention, I think I'm going to need your help. So we do map a little bit of data in my shop in Oxford. We do map CPRD, we do map some other data sets, but not a lot. I don't think we are experts like industrial mappers of data. There are people out there who are much faster than us. Still, what we have is an agreement that we map the new refresh of data every X month, and that can be monthly, 3 monthly, 6 monthly. What I have learned from my team's efforts is that the first time around is a really big investment, but the follow-up investments are much smaller because you're basically reusing most of your code. You might need to tweak things because vocabularies change and like new conditions emerge and there are new medicines, but the effort is much smaller. Mui, do you want to say something else?
Yeah, so it depends on the institution, right? And the technology that they use, right? Like you said, your group, they're not so technical. So you guys, they don't do it often. Some places they refresh it once a month, and it could be manual, right? Some places like Korea, they've developed daily ETL, so where automatically updates daily, right? We update on a monthly basis. Most of it is automated. But the one thing that typically we do have to look at is the medical code mapping, because you may have new ones, right? So you have to spend the time to make sure that that is updated. But unless your file structure change, most of the time you can set up these automatically, and it doesn't have to be using licensed tools. You could use free ones, right? Like if you use Jenkins is free, and it sets up a schedule where it automatically you tell it run this, and this, and it'll automatically do it. So it really depends on your technical expertise inside your company.
So then, if somebody maps one data, and then some other people can ask the data vendor to let them use the already mapped data, or all these data residing in the data partner for sure, but the license sort of things, it's only restricted to the people who did the mapping or some stuff like that.
So one thing I want to say about OHDSI, we say we have 300 something more databases out there, right? We have lots of databases out there, but they belong to the data owners. They don't belong to OHDSI, and there's no one central place where all this data sits. I own my data, he owns his data, Professor Yagi-san owns his data, Chan owns his own data. If you want to collaborate with them, you have to work with them, right? Whether it be through a OHDSI publication, where then if like we say, yes, we will contribute our data for free, or whether it be you licensing it from IQVIA, right? So it depends on the scenario, and so that doesn't change, right? How you get access to the data doesn't change. The open model does not change that in any way, shape, or form.
Is it fair to say that people who have unlicensed data will typically have the source and the OMOP version, and you can ask for either or both? Is that how it works, more or less?
Yeah, at a service fee. Yeah, just this much more, right?
you're talking the commercial entity here, right? But it depends, right? Again, with academics, they have both as well, but they may just work with the IRB and you use it, right? But even academics, same thing, like Darwin, they get paid for it, right? The academics get paid for it to use the data. So it really depends on the project and what the purpose is. A bunch of the studies that you saw, I showed, and some of the ones that you showed, those are OHDSI studies. So those are voluntary, they're free, right? So it's who wants to participate in the study, then you contribute to it because it's the community we're contributing to.
You had a second question or not?
First question.
Yeah, that's two. Yeah.
Yes, too?
Yes.
Did you? Okay. Well, you know where to find me. It's
Where do you go to find this? Where is this?
Thank you for your presentation. So far, it seems that Eden and Darwin is very successful. But I think the next point to discuss is sustainability. So what do you think is the challenge for Darwin to continue this initiative and grow or even more?
Yeah, thank you. So they are very different beasts, Darwin and Eden. Eden was a European grant that is coming to an end in October. So that funding will finish. There might be other grants that we're writing because that's what I do for a living, but writing grants. So maybe some of those grants will help the sustainability, but the plan for sustainability goes beyond the grant. And we have set up a non-for-profit institution called Eden Foundation, where all the colleagues who mapped the data for MOC will be invited to join and participate in and lead potentially studies. And anyone who has funding and ideas will be, contributing those two things to make this sustainable. I am not sure whether the 187 partners in Eden will be participating, because of course that depends on them in the first place, and also on the appetite of people out there to use their data, right? But I'm pretty sure that there's going to be a healthy pipeline of data partners who will continue to refer the data and participate in this Eden Foundation venture. I think we have by now, I would say 70 institutions that have signed a memorandum of understanding and are now reviewing a framework contract so that we can do studies together when the project ends. Eden is an IMI grant. This is a public-private kind of funding stream. So there's also pharma companies involved who might want to do studies as well. So we are looking into how the Eden network will be sustainable, but we have very good plans for that. Darwin is fully funded by the European Commission under the remit of the European Medicines Agency. So in principle, the EMA, the European Medicines Agency, if they want to continue with Darwin in the future, which I hope they will need to get, again, another batch of funding and then probably open another tender, and we will probably apply again and see who wins. But that Darwin EU depends on public money for now. I don't know what the sustainability is for the future. That's not for me to figure out because I'm the one doing the 70 studies, not the one getting the money.